And now we come to the topic of optics. In this video, we take a look at the concept of light. Light is an electromagnetic wave. It's basically a traveling wave comprised of an electric field component and a magnetic field component. So, the blue line in the figure, you have the electric field component, and the red line, you have the magnetic field component. You can think of the electromagnetic wave as basically two waves. You have disturbances in electric field, you have an electric field wave, and you have disturbances in magnetic field, you have a magnetic field wave. Basically, you have the electric field component and the magnetic field component. These two components are coupled together, meaning they move as one, and they are perpendicular to each other. In this figure, the electric field component is lying on the XY plane, while the magnetic field component is lying on the XZ plane. They are perpendicular with respect to each other. You have an electromagnetic wave. While the electromagnetic wave can travel through a medium, light can travel through air, can travel through water, and so on. Light or the electromagnetic wave does not need a medium in order to exist and propagate. Unlike a mechanical wave without a physical medium, a mechanical wave cannot exist and propagate. While an electromagnetic wave does not need the medium in order to exist and propagate. In vacuum, light has a speed given by c. The speed of light is c is equal to 3 times 10 to the 8 power meters per second in vacuum. There are different types or spectra of light or electromagnetic wave, and these spectra include radio waves, microwaves, infrared light, visible light, ultraviolet light, X-rays, and gamma rays. These are all examples of electromagnetic wave, and they differ in terms of their frequency range. Since light is a wave that travels in all directions from the source, the intensity of light is given by I is equal to power of the source. Say you have a source. Say you have a light bulb. You turn on the light bulb. Light will travel away from the light bulb in all directions. Think of it in terms of 3 dimensions, not only in terms of the plane of the screen. Light is also traveling into the screen and out of the screen. You can think of the concentric circles as concentric spheres. As light travels away from the source, the area upon which light is spread out on becomes bigger. And the area is surface area of the corresponding sphere. And the intensity of light is equal to power of that source divided by the surface area of the sphere upon which the light is spread out on. And as light travels away from the source, the sphere, the surface area of the sphere upon which the light is spread out on becomes bigger. I is equal to power of the source divided by surface area upon which the light is spread out on, P divided by A. Power of the source divided by surface area. And since we're talking about sphere, surface area of a sphere. Again, think of this in terms of 3 dimensions. Instead of concentric circles, you have concentric spheres. Surface area of a sphere is given by 4 pi r squared, where r is the distance of the point from the source, and I is intensity of light at that particular point. I is equal to power of the source divided by 4 pi r squared. And the farther away from the source, the bigger the denominator, the smaller the intensity of light gets. So intensity of light, I is equal to power of the source divided by surface area upon which the light is spread out on. I is equal to P over A. As such, light is subject to the inverse square law. Say you have the source and we consider 2 points, point 1 and point 2. Point 1 is distance R1 from the source. Point 2 is distance R2 from the source. At point 1, the intensity of light is I1. And at point 2, the intensity of light is I2. The inverse square law tells us I1 divided by I2 is equal to R2 squared divided by R1 squared. The inverse square law. And this tells us that if you know the intensity at one point, you can determine the intensity at another point even without knowing the power of the source. Say you know I1, you know R1 and R2. Without knowing the power of the source, we are able to determine the intensity I2. Determine the intensity at another point even without knowing the power of the source. For a more complete picture on light or electromagnetic wave, you might want to look up the concept of polarization of light. It has something to do with the orientation of the electric field component of the electromagnetic wave. And that's it for now. That's it for our discussion on the concept of light. We'll continue our discussion on optics in the next video. In the next video, we take a look at the reflection and refraction of light. So again, that's it for now. And thank you for watching.